Tankless water heaters are also called instantaneous, continuous flow, inline, flash, on demand, or instant-on water heaters are gaining in popularity. These high-power water heaters instantly heat water as it flows through the device, and do not retain any water internally except for what is in the heat exchanger coil. Copper heat exchangers are preferred in these units because of their high thermal conductivity and ease of fabrication. Tankless heaters may be installed throughout a household at more than one point of use, far from a central water heater, or larger centralized models may still be used to provide all the hot water requirements for an entire house. The main advantages of tankless water heaters are a plentiful continuous flow of hot water, and potential energy savings under some conditions. The main disadvantage of these systems are their high initial costs. Operation: the heater is normally turned off, but is equipped with flow sensors which activate it when water travels through them. A negative feedback loop is used to bring water to the target temperature. The water circulates through a copper heat exchanger and is warmed by gas or electrical heating. Since there is no finite tank of hot water that can be depleted, the heater provides a continuous supply. To protect the units in acidic environments, durable coatings or other surface treatments are available. Acid-resistant coatings are capable of withstanding temperatures of 1000 degrees Celsius. Combination boilers, combination or combi boilers combine the central heating with domestic hot water in one device. When DHW is used, a combination boiler stops pumping water to the heating circuit and diverts all the boiler's power to heating DHW. Some combis have small internal water storage vessels combining the energy of the stored water and the gas or oil burner to give faster DHW at the taps or to increase the DHW flow rate. Combination boilers are rated by the DHW flow rate. The kilowatt ratings for domestic units are typically 24 kilowatts to 54 kilowatts, giving approximate flow rates of 9 to 23 liters per minute. Larger units are used in commercial and institutional applications, or for multiple unit dwellings. High flow rate models can simultaneously supply 2 showers. Combination boilers require less space than conventional tank systems, and are significantly cheaper to install, since water tanks and associated pipes and controls are not required. Another advantage is that more than one unit may be used to supply separate heating zones or multiple bathrooms, giving greater time and temperature control. For example, one combi might supply the downstairs heating system and another the upstairs. Having 2 units can protect against complete loss of heating and DHW in the event that one unit fails, provided that the 2 systems are connected with valves that are normally closed. Combination boilers are popular in Europe, where in some countries market share is 70%. They do have disadvantages, however. The water flow rate is usually less than from a storage cylinder, particularly in winter. The power rating must match heating requirements. Heating water on demand unregistered trademark improves energy efficiency but limits the volume of water available at any moment. The water supply pressure must not be too low. Some have proposed that a flow regulator valve can control the amount of water used. Combination boilers have more moving parts that can break down, and so can be less reliable than tank systems. Point-of-use tankless types. Point-of-use tankless water heaters are located immediately where the water is being used, so the water is almost instantly hot, which reduces water wastage. POU tankless heaters also can save more energy than centrally installed tankless water heaters, because no hot water is left in lengthy supply pipes after the flow is shut off. However, POU tankless water heaters are often installed in combination with a central water heater, since the former type have usually been limited to under 6 liters per minute, which is sufficient for only light usage. In many situations, the initial expense of buying and installing a separate POU heater for every kitchen, laundry room, bathroom, and sink can outweigh the money saved in water and energy bills. In the US, POU water heaters until recently were almost always electrical, and electricity is often substantially more expensive than natural gas or propane. In recent years, higher capacity tankless heaters have become more widely available, but their feasibility may still be limited by the infrastructure's ability to furnish energy fast enough to meet peak hot water demand. In the past, tank-type water heaters have been used to compensate for lower energy delivery capacities, and they're still useful when the energy infrastructure may have a limited capacity, often reflected in peak demand energy surcharges. In theory, tankless heaters can always be somewhat more efficient than storage tank water heaters. In both kinds of installation, the absence of a tank saves energy compared to conventional tank-type water heaters, which have to reheat the water in the tank as it cools off while waiting for use. In some installations, the energy lost by a tanked heater located inside a building merely helps to heat the occupied space. This is true for an electric unit, but for a gas unit some of this lost energy leaves through the exhaust vent. However, if at any time the building must be cooled to maintain comfortable temperatures, the heat lost from a hot water tank located in the conditioned space must be removed by the air conditioning system, thus requiring larger cooling capacity and energy usage. With a central water heater of any type, any cold water standing in the pipes between the heater and the point of use is dumped down the drain as hot water travels from the heater. This water wastage can be avoided if a recirculator pump is installed, but at the cost of the energy to run the pump, plus the energy to reheat the water recirculated through the pipes. Some recirculating systems reduce standby loss by operating only at select times turning off late at night, for example. This saves energy at the expense of greater system complexity. Hybrid tankless water heaters. A hybrid water heater is a water heating system that integrates technology traits from both the tank-type water heaters and the tankless water heaters. The hybrid water heater maintains water pressure and consistent supply of hot water across multiple hot water applications, and like its tankless cousins, the hybrid is efficient and can supply a continuous flow of hot water on demand. The hybrid approach is designed to eliminate general shortcomings of other technologies. For example, hybrids are activated by either thermostat or flow. Hybrids have small storage tanks that temper incoming cold water. This means hybrids only have to increase water temperature from warm to hot as opposed to tankless, which is to raise completely cold water to hot. The defining characteristics of a hybrid water heater are, a combination of water flow of tank and efficiency of tankless of water heater, built-in small storage water reservoir as part of heat exchanger, dual activation, flow sensing and thermostat control. Hybrid water heaters can be gas-fired, or be electrically powered using a combination of heat pump and conventional electric heating element. Operation equals, a gas hybrid water heater uses a modulating infrared burner that is triggered by water flow or thermostat. The multi-pass heat exchanger drives heat down then recycles it through baffled pipes for maximum efficiency. Water fills the reservoir from bottom up and spreads evenly around the heating pipes, producing continuous hot water with consistent pressure and temperature. During low-flow situations, the hybrid behaves like a tank-type heater by having minimum fixed fuel usage and thermostat activation. Although equipped with some storage capacity, the small volume minimizes standby fuel usage. Hybrids also share additional traits with tank-type heaters like a floor-standing installation, standard PVC venting, draining pan, and they can be installed with a recirculation pump for even more water efficiency. During high-demand, high-flow situations, hybrid technology behaves more like a tankless heater, with high British thermal unit capacity and full modulation to supply a continuous stream of hot water across multiple applications. This produces fuel efficiencies similar to tankless heaters, but with higher flow capacity. Efficiency equals. Tankless heater controls. Tankless water heaters can be further divided into two categories according to their heating capability, full-on full-off, versus modulated. Full-on full-off units do not have a variable power output level. The unit is either fully on or completely off. This can cause an annoying and possibly hazardous variation of hot water temperature, as the flow of water through the heater varies. Modulated tankless water heaters change their heat outputs in response to the flow rate of water running through the unit. This is usually done by using a flow sensor, a modulating gas valve, an inlet water temperature sensor, and an outlet water temperature sensor choke valve. A properly configured modulating heater can supply the same output temperature of water at differing water flow rates within their rated capacity, usually maintaining a close range of A plus or minus 2 degrees Celsius. A high-efficiency condensing combination boiler provides both space heating and water heating, and is an increasingly popular choice in UK houses. In fact, combination boilers now account for over half of all the new domestic boilers installed in Britain. Under current North American conditions, the most cost-effective configuration from an operating viewpoint often is to install a central water heater for most of the house, and to install a POU tankless water heater at any distant faucets or bathrooms. However, the most economic design may vary according to the relative electricity, gas and water prices in the locality, the layout of the building, and how much hot water is used. Only electric tankless water heaters were widely available for many years and they're still used for low initial cost POU heaters, but natural gas and propane POU heaters have now become available for consideration. Tankless advantages. Tankless water heaters provide many advantages. Long-term energy savings. Though a tankless water heater typically costs more initially, it usually costs less to operate because of lower energy use since it only heats water when required instead of continuously maintaining a tank of heated water. Even homes or buildings with high demand for hot water may realize some level of savings. If instant hot water at taps at limited hours is a priority, a recirculation system can be accommodated by using an aquastat and timer to decrease the added heat loss from the recirculation system. If the storage tank of an electric heater is highly insulated, so that the outer surface of the tank is only slightly warmer than the ambient air, the savings with a tankless heater is less. Savings in water use. Users in remote points in the building do not have to run the hot water as long waiting for it to get to the faucet. Unlimited hot water. Though flow rate determines the amount of hot water the heater can produce, it can deliver it at that flow rate indefinitely. However, this can also be an ecological disadvantage, as running out of hot water limits use, but a tankless heater provides no such limit. Less physical space. Most tankless water heaters can be mounted on a wall or internally in a building's structure. This means less physical space must be dedicated to heating water. Even systems that can't be mounted on walls take up less space than a tank-type water heater. Reduced risk of water damage. No stored water means there is no risk of water damage from a tank failure or rupture, though pipe or fitting failure remains possible. Temperature compensation. A temperature compensating valve tends to eliminate the issue where the temperature and pressure from tankless heaters decrease during continuous use. Most new generation tankless water heaters stabilize water pressure and temperature by a bypass valve and a mixing valve incorporated in the unit. Modern tankless are not inversely proportional, because they regulate the amount of water they heat and discharge, and therefore stabilize water temperature by using a flow control valve. Temperature change, not flow speed, is the issue the water heater must address. The wider the temperature rise, the less flow from the unit. The smaller the temperature rise, the greater the flow. The flow control valve, in conjunction with thermistors, maintains a stable temperature throughout the use of the unit. Safety. Tankless water heaters precisely control water temperature, which means dangerous temperature levels and spikes are less likely. An additional safety advantage stems from reduced exposure to dissolved toxic metals, which tend to occur at higher concentrations in hot water which has resided in a conventional water heater tank for significant periods of time. Tankless disadvantages. Startup costs. Beyond the 2x-4x larger initial purchase price, installing a tankless system comes at an increased cost, particularly in retrofit applications. They tend to be particularly expensive in areas such as the US where they are not dominant, compared to the established tank design. If a storage water heater is replaced with a tankless one, the installer may have to increase the size of the electrical wiring or gas pipeline to handle the load, and replace the existing vent pipe, possibly adding expense to the retrofit. Many tankless units have fully modulating gas valves that range from as low as 10,000 to over 1 million BTUs. Most electrical installations require 10 Auban florins or 8-wire, corresponding to 5.5 or 8.5 mm 2 for typical POU heaters at North American voltages. Larger whole-house electric units may require up to 2 Auban florins wire. In gas appliances, both pressure and volume requirements must be met for optimum operation. Startup delay: there may be a longer wait for hot water. A tankless water heater only heats water on demand, so idle water in the piping starts at room temperature. Thus, there may be a more apparent flow delay for hot water to reach a distant faucet. Many models sold in the UK have introduced a small heat store within the combination boiler to address this issue. This Keep Hot facility considerably improves the standard of hot water service, which some people otherwise find unacceptably poor with a combination boiler, but it uses considerably more fuel, especially in summer. Intermittent use: there is a short delay between when the water begins to flow and when the heater's flow detector activates the heating elements or gas burner. In the case of continuous use applications, this is not an issue as the heater never stops heating. However, for intermittent use applications, this can result in initially hot water, followed by a small amount of cold water as the heater reactivates, followed again by hot water. This is particularly an issue if hot water pipes are poorly insulated. The user experiences that after initially getting hot water flowing, the user turns off the valve and then a short time later turns the valve back on again. Hot water starts flowing once again at the valve from the hot water already in the piping, but at the same time, some heaters must let some amount of cold water into the piping during the reactivation time. Sometime later this cold section of water arrives at the sink, followed shortly thereafter by hot water again. The initial thought of the user can be that the heater is failing intermittently. Heat source flexibility: tankless heaters use either gas and electricity for heat. Their design may not conveniently allow other heat sources, including certain renewable energy options. One exception is solar water heating, which can be used in conjunction with tankless water heaters. Tank-type systems can use many heat sources such as district heating, central heating, geothermal heating, micro-CHP and ground-coupled heat exchangers. Recirculation systems: since a tankless water heater is inactive when hot water is not being used, they are incompatible with passive hot water recirculation systems. They may be incompatible with active hot water recirculation systems and certainly use more energy to constantly heat water within the piping, defeating one of a tankless water heater's primary advantages. On-demand recirculating pumps are often used to minimize hot water wait times from tankless water heaters and save water being wasted down the drain. On-demand recirculating pumps are activated by push-button or other sensor. A water contacting temperature probe installed at the hot water usage point signals the pump to stop. Single-cycle pumping events only occur when hot water is needed, thereby preventing the energy waste associated with constantly heating water within piping. Achieving cooler temperatures: tankless water heaters often have minimum flow requirements before the heater is activated, and this can result in a gap between the cold water temperature and the coolest warm water temperature that can be achieved with a hot and cold water mix. Maintaining constant shower temperature: similarly, unlike with a tank heater, the hot water temperature from a non-modulated tankless heater is inversely proportional to the rate of the water flow. The faster the flow, the less time the water spends in the heating element being heated. Mixing hot and cold water to the right temperature from a single lever faucet takes some practice. Also, when adjusting the mixture in mid-shower, the change in temperature initially reacts as a tanked heater does, but this also changes the flow rate of hot water. Therefore, some finite time later the temperature changes again very slightly and requires readjustment. This is typically not noticeable in non-shower applications. Operation with low supply pressure: tankless systems are reliant on the water pressure that is delivered to the property. In other words, if a tankless system is used to deliver water to a shower or water faucet, the pressure is the same as the pressure delivered to the property and cannot be increased, whereas in tanked systems the tanks can be positioned above the water outlets so the force of gravity can assist in delivering the water, and pumps can be added into the system to increase pressure. Power showers, for example, cannot be used with tankless systems because the tankless systems cannot deliver the hot water at a fast enough flow rate required by the pump. Time of use metering and peak electrical loads. Tankless electric heaters, if installed in a large percentage of homes within an area, can create demand management problems for electrical utilities. Because these are high-current devices, and hot water use tends to peak at certain times of the day, their use can cause short spikes in electricity demand, including during the daily peak electrical load periods, which increases utility operating costs. For households using time-of-use metering, a tankless electric heater may actually increase operating costs if the hot water is used during peak times. Instantaneous type heaters are also problematic if they are connected to district heating systems, as they raise peak demands, and most utilities prefer all buildings to have hot water storage. References